Okay, this is lesson 12.3b. It's just a little bit more about the hyperbola. So this time we're going to look at a graph and try to write the equation. So just looking at it, you can tell that this looks like the vertex here. This is another vertex point. So the transverse axis goes vertical there. So this is definitely a vertical ellipse. We could even start, just kind of write the formula. We know it starts with y squared minus x squared because it's vertical. Equals 1. It's always, for both hyperbolas, a squared and b squared in that order. We just need to figure out some of those items. What is a? What is b? Well, the distance from the vertex to the center is always called a. So a is equal to 3. So right away we know that that's going to be 3 squared. We're almost done. Just got to figure out what b is. It's hard to see the dot box here. You may not see it. If you do see it, I see that's the vertex, so I would go straight over from that, hit the asymptote. I think that is actually the dot box there, but if you don't see that, that's okay. We can look at the slope of this line. So it looks like the equation of this line has a slope of 3 over 1, so y equals plus or minus 3 x. The slope is 3 or negative 3, depending on which way you go on the asymptote. So the formula for this one, for vertical, let's look back at vertical. Formula is a over b, slope. So if the formula is y equals plus or minus a over b times x, then we know that 3 equals a over b. So you can set up an equation. So a over b equals 3, or 3 equals a over b. We know that a is 3. So right here we can plug in a 3. And probably without solving it, you know that b is 1. If you need to cross multiply that and solve it, you certainly can. 3 equals 3b divided by 3. You get b equal to 1. So we now have our equation of b equals 1 here. So I don't care how you get it. You can look at a graph and figure out stuff pretty quickly. Now this one's a little different. We are given the vertex. That's kind of a tough vertex. Vertex points there are positive 2 root 3 and negative 2 root 3 for the x values. So this one looks like a horizontal ellipse. So the formula is going to be x squared minus y squared if it's horizontal. And for both formulas, a squared is the first term below there, and then b squared. So we know the distance from the center to the vertex is a. So a would be 2 root 3. So this is going to be kind of weird to write it, but let's say 2 root 3. We can simplify this in a minute. Squared. That's our a squared. Have to figure out what b is. May not be as obvious now because it almost looks like that's part of the dot box, but it's not on the same x value there, so there's no dot box there. That's just a point. And looking at what we've done before with this, I would highly recommend writing x and y below that to remind you that, oh yeah, maybe I could plug it into that equation. So this would be 4 squared, or 16, minus 16 equals 1 over b squared. And let's see, 2 root 3 would be 2 squared, which is 4, and square root of 3 squared, which is 3. 4 times 3 is 12. Let's see, does that simplify? That would be 4 goes into that, 4 over 3. So we got 4 thirds minus 16 over b squared equals 1. I'm going to subtract 4 thirds from both sides. That cancels. I get negative 16 over b squared equals 3 thirds minus 1 third is negative 1 third. Cross multiply this guy, you get negative 48 equals negative b squared. divided by -1, b squared equals 48. Take the square root of both sides. Don't worry about plus or minus. B is always positive. B equals square root of 48. Let's think about square root of 48. So that would be 48. So any perfect squares in there. 6, 2, and 3. I have a pair of 2s and another pair of 2s with a 3 left over. So this would be 2 times 2 is 4 root 3 inside of the radical there is root 3. And so I know that my b value is 4 root 3, so I would put that in here. 4 root 3 squared would be, what, 16 times 3 is 48. Well, that makes sense. Square root of 48 squared is 48. And so we have our equation. So I think you've probably seen enough hyperbolas to keep working on homework, do your homework in class today, and that's where you're at. Just a quick lesson on hyperbola.